Across the unfathomable darkness, a signal travels. It is a whisper of data, a phantom stream of ones and zeros crossing a gulf of silence so profound it defies human comprehension. This faint transmission is our species' most audacious greeting card, a message in a cosmic bottle tossed into an endless star-dusted ocean. It speaks of our existence, our science, our art, our hope. But before we could send our voice to the stars, we first had to learn how to cross the waters of our own world. An answer to how we might survive the coming journey lies not in our gleaming laboratories or advanced propulsion systems alone. It is hidden in the past, etched in the memory of salt and wind, and carried in the stories of a people who conquered a planetary ocean with vessels woven from plants and a courage forged by necessity. To understand our future on a world like Mars, we must first look back to the greatest feat of exploration in human history, the settlement of the Pacific. Imagine an expanse of water that occupies nearly a third of our world's surface. This is the Pacific Ocean, a liquid continent of staggering proportions. Its sheer immensity is a challenge to the modern mind, let alone to the ancient mariners who faced it without compass or chronometer. For centuries, European explorers believed this great void was impassable, a blue desert punctuated by islands they stumbled upon by chance. They were wrong. Thousands of years before Magellan's circumnavigation, a civilization was undertaking a deliberate, systematic, and breathtaking expansion across this very emptiness. They were the Austronesian peoples, the ancestors of modern Polynesians. From their ancestral homelands in Southeast Asia, they began a migration that would last for millennia, a patient island by island march into the heart of the great ocean. Their vessels were not crude rafts, but sophisticated double-hulled canoes, the times wa'akaulua, times masterpieces of Neolithic engineering. These were cathedrals of wood and fibre, capable of carrying dozens of people along with their plants, their animals, and the fire of their culture across thousands of kilometers of open, often violent sea. Consider the vessel itself as the first lesson for our interplanetary ambitions. Each canoe was a self-contained biosphere, a microcosm of the world they had left behind. On its decks, carefully shielded from salt water, were the essentials for a new beginning. Taro corms, breadfruit saplings, sprouting coconuts and sugarcane. In pens they carried pigs, dogs and chickens, a genetic starter pack for a new world. The canoe was not merely a transport, it was an ark. It was a sealed environment, a life support system where every resource was precious, every calorie counted, and every drop of fresh water was rationed. This is the fundamental principle of any long-duration spacecraft. Our starships destined for Mars will be the direct technological descendants of these canoes. They will be hermetically sealed arks, recycling every breath of air, every molecule of water, and every nutrient of waste. Hydroponic bays will glow with artificial sunlight, nurturing crops in a perfect parallel to the sheltered plants on the ancient Polynesian decks. The hum of the environmental control systems will be the modern chant that replaces the rhythmic slap of waves against a wooden hull. The challenge of creating a stable, self-sufficient ecosystem for a months-long journey is the same problem the Pacific voyagers solved with organic materials and generational wisdom. But having the right vessel is only the first part of the puzzle. The true genius of the Polynesian migration was not in their ships, but in their minds. They navigated without instruments, using a library of knowledge passed down through generations, a mental map of the ocean itself. They read the sky like a book, recognizing hundreds of stars, knowing their precise rising and setting points throughout the year. Their celestial compass was not a magnetic needle, but a web of star paths, a dome of constellations that wheeled overhead, guiding them with unerring accuracy. This intricate system of knowledge allowed a navigator to hold a course through nights of impenetrable blackness, maintaining their heading by the memory of which star should be over the bow at any given hour. Imagine the scene: a lone navigator standing on the pitching deck, the wind whipping through his hair, the roar of the ocean, a constant companion. He feels the rhythm of the sea not just with his ears but with his entire body. He is sensing the deep, persistent ocean swells born in distant storms thousands of kilometers away. These long, stable waves march relentlessly across the ocean basin. Even when clouds obscure the stars, he can feel the subtle shift in the canoe's motion as it interacts with these swells, telling him if he is holding his course. He is a human gyroscope, attuned to the planet's fundamental frequencies. And there was more. The Pacific navigators were masters of environmental observation. They understood how remote islands far below the horizon could project their presence. They watched for subtle changes in wave patterns as swells refracted and bent around unseen landmasses, creating a distinctive, confused pattern on the water's surface that could be detected from afar. They observed the flight paths of migratory birds, knowing that certain species would fly out to sea to fish during the day, but must return to land at dusk. Following them at the right time of day could lead directly to an undiscovered island. They could even read the clouds, as stationary cloud formations often linger over the warm, moist air that rises from an island, a telltale sign of land just beyond the visible curve of the Earth. This was a science of sublime subtlety, a deep communion with the natural world. Our own journey to Mars will require a similarly profound understanding of a new environment. Our navigators will not feel the ocean swells, but they will sense the invisible tides of gravity. Their star charts will not be memorized, but will be calculated by computers running complex orbital mechanics simulations to thread the needle through planetary alignments. They will read the weather of interplanetary space, monitoring the solar wind, and watching for coronal mass ejections, great storms of radiation that could prove lethal to an unshielded crew. Their deep space network will be the modern equivalent of watching seabirds sending and receiving faint signals that confirm their position and trajectory. The knowledge required is different in form but identical in its fundamental purpose: to interpret the subtle signs of a vast and hostile environment to ensure safe passage. The most crucial lesson from the Pacific model, however, is the strategy of the migration itself. It was not a single desperate leap from one shore to the unknown. It was a methodical, generational process of island hopping. The Polynesian expansion can be visualized as a slow-burning fire spreading across a network of fuel sources. A group would settle an island, perhaps Tahiti. They would spend generations there, building their population, cultivating the land, and accumulating the resources necessary for the next great voyage. Their knowledge of the surrounding sea would grow based on scouting expeditions and fishing trips. They established a secure base, a vibrant center of civilization. From this established hub, a new expedition would be launched. It would not be a voyage of desperation, but a planned colonization effort. A new canoe or a small fleet would set out, not randomly but targeted toward a region where signs of land had been observed. They would journey to a new island, say in the Marquesas. If they found it habitable, they would settle, establishing a new outpost of their culture. This new settlement would in turn, after generations of consolidation, become the launching point for the next step, pushing ever further into the unknown towards Rapa Nui, towards Hawaii, towards Aotearoa. It was a network of stepping stones, each one a self-sufficient world linked by shared culture, language, and the technology of the voyaging canoe. This is the blueprint for humanity's expansion into the solar system. Mars is not our first stop after leaving home. The Pacific model dictates that we must first establish a base on a closer island. That island is Earth's own moon. The Artemis program, NASA's ambitious plan to return humans to the lunar surface, is not merely a sentimental journey to recapture the glory of Apollo. It is the strategic establishment of our first off-world Tahiti. A permanent lunar base, a gateway in orbit, is the essential first step. On the moon, we will learn the hard lessons of long-term survival beyond Earth's protective magnetosphere. We will learn to build habitats from local materials using lunar regolith to 3D print structures that can shield us from cosmic radiation and micrometeorites. We will learn to extract resources, a practice known as in-situ resource utilization. The most vital of these resources is water locked away as ice in the permanently shadowed craters of the lunar poles. This water is not just for drinking. Through electrolysis, it can be split into hydrogen and oxygen, the most powerful chemical rocket propellant known. The moon will become our off-world refueling station. Future Mars-bound ships will not need to fight their way out of Earth's deep gravity well with all their fuel. They will be assembled and fueled in orbit or launched from the moon itself, saving incredible amounts of energy and enabling far more ambitious missions. Just as the Polynesians spent generations mastering their home island before the next voyage, we will spend years, perhaps decades, mastering the moon. We will test our closed-loop life support systems, our advanced rovers, our deep space communication technologies, and crucially ourselves. We will study the long-term physiological and psychological effects of living in a low-gravity, high-radiation environment. The moon is our proving ground, our laboratory, our shipyard. It is the place where we transition from being Earth-bound visitors to space into true spacefaring citizens of the solar system. Only from this position of strength, from this established base, can we launch the next far more perilous voyage across the much larger ocean of space to Mars. The journey to Mars itself will be a 9-month odyssey, a period of intense isolation and confinement far exceeding anything experienced on the moon. The psychological toll will be immense. Here too, the Polynesian model offers profound wisdom. The crews of the voyaging canoes were not collections of individuals, they were a community. They were often extended families bound by kinship and a shared cultural purpose. Their social structures were robust with clear leadership and defined roles for every person. Their survival depended on absolute cooperation, trust, and mutual support. They carried with them their songs, their stories, their rituals, a cultural toolkit that provided resilience in the face of unimaginable hardship. The first crews to travel to Mars must be selected with this in mind. They will be more than just brilliant scientists and skilled engineers. They must be a cohesive, psychologically robust, and mutually supportive team. The right stuff for a Mars mission is not just about courage and technical skill. It is about empathy, emotional stability, and an unwavering commitment to the group's welfare. The first Martians will spend years together, first on the transit vehicle and then in a small, isolated habitat on a silent alien world. Their survival will hinge on their ability to function as a tightly knit tribe, a family forged not by blood, but by a shared extraordinary destiny. Their psychological health will be as critical as the integrity of their habitat's hull. And what of arrival, the Polynesians sometimes arrived at islands that were hostile or barren, forcing them to turn back or perish. This was the ultimate risk of their ventures. Scouting was essential. The oral traditions speak of explorers who made two-way voyages, venturing out to find new land, and then returning with the knowledge of its location and suitability before mounting a full colonization effort. This parallels our own robotic exploration program. For decades, we have been sending our robotic scouts to Mars. Orbiters have mapped its surface in exquisite detail, rovers have tasted its soil and analyzed its rocks, and landers have listened for its faint seismic heartbeat. These robotic precursors are our two-way scouting missions. They have confirmed the presence of vast reserves of water ice just below the surface, the single most important resource for any human settlement. They have identified potential landing sites that are flat, safe, and resource-rich. They have characterized the deadly radiation environment and the thin carbon dioxide atmosphere. We will not be arriving blind. Thanks to our tireless robotic explorers, the first humans to step onto Mars will do so with more knowledge of their new world than any ancient Polynesian navigator had of the island they sought over the horizon. They will know where to land, where to find water, and what dangers to expect. This robotic reconnaissance minimizes the risk and maximizes the chance of establishing a permanent foothold. Once a foothold is gained, the Polynesian model continues to guide our thinking. The first settlement on a new island was a monumental effort of labor. Forests had to be cleared, fields had to be planted with the transported crops, and shelters had to be built. The settlers fundamentally reshaped their new environment to support human life, transforming the island's ecosystem into one that could sustain them. They were, in a very real sense, the first terraformers. They brought their familiar world with them and imprinted it upon the new one. The first Martian outpost will begin in the same way, albeit on a technological level. The first fields will be inside inflatable greenhouses under the purple glow of LED lights. The first shelters will be prefabricated habitats buried under several meters of Martian regolith for radiation shielding. The first act of the settlers will be to begin the process of making Mars just a little bit more like Earth. They will deploy solar arrays to capture the faint sunlight, use drills and heaters to extract the subsurface water ice, and deploy chemical plants that can crack carbon dioxide from the atmosphere to produce oxygen for breathing and methane for rocket fuel. This last part is revolutionary. The ability to manufacture rocket fuel on Mars is what turns a one-way expedition into a sustainable two-way transportation system. It is what allows Mars to become not just a destination, but a true independent outpost of humanity. For centuries, perhaps millennia, humanity on Mars will live within these enclosed biospheres. They will create a network of settlements expanding from the initial landing site. These settlements might specialize, one focused on mining, another on scientific research, a third on advanced manufacturing. They will be connected by pressurized rovers, or perhaps eventually a suborbital transport system. A new civilization will take root, a Martian culture with its own traditions, its own art, and its own way of seeing the universe, shaped by the stark beauty and unforgiving nature of their crimson world. They will be Martians, a new branch of the human family tree. But the ultimate expression of the Polynesian legacy is the grand, audacious dream of terraforming. Just as the ancient voyagers transformed the islands they settled, could we one day transform the entire planet of Mars? The idea is no longer pure science fiction. We know what is required. We must thicken the atmosphere and warm the planet. A thicker atmosphere would provide better radiation shielding, allow liquid water to be stable on the surface, and create enough pressure for humans to one day walk outside with a simple breathing apparatus, instead of a full pressure, a suit. The process would be planetary engineering on an unimaginable scale, a project that would span centuries. It might begin by erecting giant orbital mirrors to focus sunlight onto the Martian polar ice caps, vaporizing the frozen carbon dioxide and water ice stored there. This would release massive quantities of greenhouse gases into the atmosphere, triggering a runaway warming effect. Factories on the surface could be built to pump out other, more potent super greenhouse gases. As the planet warms, the atmosphere thickens. The increased pressure and temperature would allow liquid water to flow once again in the ancient riverbeds and canyons we see today. After centuries of warming, the next phase could begin the introduction of life. We would start with the hardiest forms of terrestrial organisms, lichens and microbes capable of surviving the harsh UV radiation and thin air. These extremophiles would begin the slow, painstaking work of processing the Martian soil, fixing nitrogen, and most importantly, releasing oxygen through photosynthesis. This would be a biological project of a geological timescale. Millennia would pass as these pioneer species slowly, molecule by molecule, transform the carbon dioxide-rich atmosphere into one that contains free oxygen. Eventually, more complex plants could be introduced, turning the red deserts into green plains under a pale blue Martian sky. It is a vision so grand it borders on the hubristic, but it is the logical endpoint of the journey that began in a double-hulled canoe. It is the ultimate expression of the human impulse not just to explore but to create, to carry the spark of life and consciousness to a dead world and give it a new beginning. The people who accomplished the settlement of the Pacific demonstrated that humanity is capable of undertaking multi-generational projects of immense scale and difficulty. They were driven by a complex mix of pressures, population growth, resource scarcity, conflict, but also by an innate spirit of adventure, a yearning to see what lay beyond the horizon. That same spirit animates our push towards the stars today. We are driven by the scientific imperative to understand our place in the cosmos, to search for life beyond Earth, and to unlock the secrets of planetary formation. We are also driven by a more pragmatic, long-term survival instinct. Spreading to another world is the ultimate insurance policy for humanity, a safeguard against the myriad threats, both natural and self-inflicted, that could one day extinguish life on our home planet. A single planet species is vulnerable. A multi-planet species has a future that is vastly more secure. The lessons are clear. Plan in stages. Establish a secure nearby base first. Master the technologies of self-sufficiency. Select your crews for psychological resilience and community cohesion. Scout extensively with robots before sending humans. Arrive with the tools not just to survive, but to build and transform. And most of all, be patient. The settlement of the Pacific took over 3,000 years. The settlement of the solar system will be a project of similar or even greater timescale. We who are alive today will not see the cities of Mars or the greening of its deserts. We are the generation that builds the first canoes. We are the generation that learns to read the new stars. We are the ones who establish the first base on the nearest shore. Our legacy will be in laying the foundation, in taking the first difficult steps that make that distant future possible. The journey across the black ocean of space is the most formidable challenge we have ever faced. The void is colder, emptier, and vastly more dangerous than any terrestrial sea. But the fundamental nature of the endeavor is the same. It is about a small group of people in a fragile vessel, carrying the hopes of their civilization with them into a vast unknown. It is a story of courage, of ingenuity, and of an unquenchable desire to move forward. The ghost of a Polynesian navigator stands beside every astronaut, a silent testament to the fact that this impulse is not new. It is the oldest, most defining characteristic of our species. We have always looked to the horizon and wondered what lies beyond. And having conquered our world's greatest ocean, we now look to the sky and prepare to set sail for the shores of another world. The voyage has already begun.